All right, you guys, this is our very last day of notes for Unit 7. And we are going to be doing the proportional similar figures again. We did this in Unit 6. Remember, we made a SPA chart. Now we're going to do it with three-dimensional figures, which means we're adding a V for volume or for our three-dimensional space, right? So now we're going to have a SPAV chart, okay? But the basic math is the exact same as what we did before, but we have to make sure we're using the appropriate ratio for the dimension that we're in. If it's an area problem, we have to be using a second dimension ratio. If it's volume, we have to be using a third dimension ratio. And if we're talking about sides or perimeter, we have to be using the ratio in one dimension. The majority of you guys that missed the questions on the test in Unit 6 did not make a SPA chart. I cannot stress the importance of making a SPAV chart in Unit 7 to organize your ratios. It literally takes 5 seconds to make a SPAV chart or a SPA chart, right? And it's totally worth the time. All right, so we're just going to fill in the blanks here. So remember, similar figures are proportional. So that's pretty much all we're going to be doing today is setting up proportions. But the proportions have to be in the same dimension, which I totally get why this throws people off, right? Because starting in middle school, right, you're just totally programmed like, oh, I see three numbers. I'll just throw them in a proportion and solve and put an X in the fourth spot and solve my proportion. But now that we're talking about all three dimensions, you have to make sure that you're in the same dimension, that all three numbers are in the same dimension. Because if they're not, then your answer is going to be totally off. All right, so really quick, let's talk about our SPAV chart. So I'm going to be basically rewriting what we did in the last unit. So I'm just going to use a general A over B ratio. All right. So remember, the perimeter ratio is always the same as the side ratio. And that would be because sides and perimeter calculations are all one-dimensional calculations, right? Then, let me make this a little bit darker. Then we have our area ratio, which remember we learned that we square when we go up a dimension, right? So when we're in 2D, everybody has to get squared. And notice the arrows. Do you see how these are the same arrows that we had in Unit 6? So I'm going to go ahead and fill those in. So we know to square to go up a dimension to area. But what if we're given the area and we want to go backwards? So remember, we do the square root. All right, so again, this is everything we learned in Unit 6, right? But now we're adding that good old 3D volume ratio. So now that we're in the third dimension, you know it, everything has to be cubed, which is why our units are cubed when we do volume, right? So our ratio is A cubed to B cubed. Now, I want you to notice that we don't have any arrows that go directly from 2D to 3D. That's super important, right? Now, it's not that you can't do it, but you guys haven't really learned about fractional powers and the exponents and all that kind of stuff yet. So that means everything's going to go back to 1D, right? So if we're in 1D land and we want to get to 3D land, we know we can just cube, right? But if we're in 3D land and we want to go all the way back to 1D land, well, then you know it, we have to cube root. Now, you might be asking yourself, well, what do I do then if I'm given an area ratio and I want to go to volume? Well, you have to follow the arrows, right? So if I'm in area, I would need to square root to get back to 1D and then cube root to get up to 3D, right? So you're just going to kind of follow the arrows to get your ratios. All right, so we're just going to do some really quick SPAV charts. We don't even have to fill in the blanks necessarily because the blanks are going to be in our SPAV charts. So here we go. Given a scale factor of 2/3. Okay, well, scale factor is the same thing as side ratio. So then our perimeter ratio would be the same. Our area ratio would be the square of 2/3, which is 4/9. And then the volume, right, is going to be the cube of the side ratio. Please don't cube the volume, right? We don't want to be in that high of a dimension, right? So if I cube 2, I get 8. And if I cube 3, I get 27. And there you go. There's your SPAV chart. If you want to write all those again down in these blanks, you totally can. All right. What if you were given, I'm going to give an example from each spot. What if we were given the area ratio of 16/49? Again, we give you pretty friendly numbers, so you don't have to worry too much. Everything's going to be a perfect square or cube usually. All right, so 16/49. Okay, well, remember, you can't go directly up here. You have to go backwards first, right? And so we're going to square root, which is going to give us 4/7, obviously here and here, right? But then we are going to cube to get up to three-dimensional land, right? So 4 cubed is 64, and 7 cubed is 343, right? So notice the numbers are starting to get pretty big for our volume ratios. That's it. All right, what about our last one? If you're given the volume ratio of 16/54. Now, neither one of those numbers are perfect cubes. However, I do notice that 16/54 is reducible, right, to 8/27, right, because they're both even numbers. So I can definitely see that they have a 2 in there. So I'm going to go ahead and reduce my fraction if I can. And then I happen to notice that it looks very friendly from that point, right? So now I'm going to take my 8/27. I have to go all the way back to 1D land, which means we're going to cube root. I'm going to write that little note here. If you need help cube rooting ever, remember the cubed root is on your calculator under the math 4 function. Math number 4 is your cube root, okay? So obviously if I cube root 8, I'm going to get 2. And if I cube root 27, I'm going to get 3. Are these the exact same numbers that were in the other one? They are. I should have used different numbers, right? And so 2/3. And then, of course, we're going to square it to hop up to 2D, which gives us 4/9. Okay? So again, it takes 5 to 10 seconds to make a SPAV chart. And then once you have all the dimensions represented, then we're going to pull out the one that we want for our math problem. Okay? So let's go do some problems. Here we go. Cylinders A and B are similar with a scale factor of 2 to 5. I'm going to stop right there. As soon as you tell me that I have similar figures and they have a scale factor of 2 to 5, I'm not even going to finish reading the problem. I'm going to go ahead and spend the next 5 seconds making a SPAV chart. So scale factor is 2 to 5. That means it's my side ratio, which means my perimeter ratio is 2 to 5, which means my area ratio is 4 to 25. And my volume ratio is 8 to 125, right? So I'm squaring and then cubing. All right, awesome. Now I'm going to finish reading the question. It says, find the surface area of cylinder B, which is clearly the larger one, right? There you go. Given that the surface area of cylinder A is 96 pi. Okay, so I'm setting up a proportion. And notice we're talking about surface area, which means I want this ratio in my proportion, okay? If it was a volume question, I would use the volume ratio. If it was a perimeter question or whatever, I would be doing the perimeter ratio. But because this is surface area, I know it has a 4 to 25 ratio because I've already made my SPAV chart. Now, the other thing I happen to notice is that, and you want to make sure you make a mental note of this, clearly we are doing small to big because the smaller numbers are on top and the bigger numbers on the bottom. So I want to make sure when it says find the surface area of cylinder B, which is clearly the bigger one, right? Then I'm going to put that on the bottom, and then cylinder A is 96 pi. And there you have it, right? There's your proportion. We just have to cross multiply and divide, and we should be set. So here we go. I'm going to use my calculator. Ooh, I have to clear all that out. 25 times 96 gives me 2400 pi equals 4x. And then, of course, I'm just dividing by 4, which is quite friendly. So 600 pi. And, of course, that's going to be square feet. And there you go. And I know my answer is correct because I used the correct dimension in my proportion. Highlight that. All right. I hope that makes sense. Here I'm going to replace that small to big, and I'm going to write A to B because that's clearly how that ratio is being set up. Okay. All right. Moving on. The lateral areas of two similar cones are 100 centimeters and 25 pi centimeters. All right. So here we go. As soon as I read that, I'm going to go over here. I'm going to make my SPAV chart over here. All right, so it's giving us their areas, lateral areas, right? So that would be 100 pi to 25 pi. Now, there's a lot of simplifying. I'm actually going to scoochie my V over here. There we go. Right, I can totally simplify this to 4 over 1. Right? So I don't really need to use all those ginormous numbers. The pi's cancel, so that means the area is 4 times bigger, right? Which, of course, if I square root that, that means my perimeter and side ratios are 2 times bigger, which means my volume is 8 times bigger, right? So as soon as I read the second sentence, so I'm going to erase that. Right, as soon as I get to here and it says the volume of the smaller one is 40 cubic centimeters, find the volume of the larger one. So right away, I'm like, oh, awesome. This is a volume question, which means I should be using the volume ratio in my proportion. Okay, so I'm going to set up my proportion. I'm going to go ahead and put my 8 to 1 in there. And then it says the volume of the smaller one is 40. Well, clearly my smaller ones are on the bottom with the ones. Find the volume of the larger one. Now, obviously, couldn't you answer this without doing a proportion? Yes, because my SPAV chart told me that the volume was 8 times bigger. So yes, I could just multiply the 8 times 40 pi without setting up a proportion. But the proportion just kind of confirms, that you're on the right track. So I like to go ahead and set that up. Let's see, give us 320 pi cubic centimeters, which, yes, is 8 times bigger than the volume of the smaller cone, which makes perfect sense. All right, moving on. I'm just going to kind of fly through these last few. This one says the volume of 2 proportional prisms is 200 to 25. All right, stopping right there, making myself a SPAV chart. They're giving me volumes of 200 to 25. All right, well, I'm going to go ahead and reduce that, which, what do you know? It also reduces to 8 to 1, right? Which means I'm going to cube root it, which means 2 to 1 for my 1D and 4 to 1. So it's the exact same SPAV chart that we just did a second ago, basically. All right, then it says the lateral area of the smaller one is 15. Find the lateral area. Okay, so once again, as soon as I read the question, I know that I'm going to be using the area formula in my ratio. Again, technically, you don't have to make a proportion, but I'm going to. So I know it's a 4 to 1 area ratio. The lateral of the smaller is 15. What is the larger one? Again, you can just multiply by 4 if you want to, right? So we're going to get x equals 60, and that's going to be square centimeters. All right, a few more. It says a cone-shaped pile of sand weighs 400 pounds. Now, this one can be, I don't know, controversial might be a good word for it, because now we're talking about weight, right? Weight by nature is a form of mass, which is a form of volume. They're not all the same thing, of course, but it is a 3-dimensional measurement technically. So I just want to make sure I throw that in there. Anytime you see a question about weight, right? Weight has to do with mass, right? Mass has to do with volume. Again, I know they're not all they're not synonyms of each other, but they are technically 3-dimensional measurements. Okay. And so whenever you see a weight problem, you are going to be calculating volume. Okay. So just so you know, when you're setting up your SPAV chart, now it says, how much does a similarly shaped pile of sand weigh if each dimension, remember dimension means side, is 4 times as large? All right, so that means my side ratio is 4 to 1 because it's 4 times larger. which means my perimeter ratio is 4 to 1, which means my area ratio is 16 to 1, which means my volume ratio is 64 to 1. And since we're talking about weight, I'm going to be using the volume ratio, which means, and again, you don't have to set up a proportion, but this means that that means our new pile of sand, right, is 64 times bigger in volume, which means it's 64 times bigger in weight as well. All right, so I'm going to go ahead and set up a proportion. Again, you don't have to. So I'm going to make sure I use that 64 to 1. And it says the cone-shaped pile of sand weighs 400 pounds. So that's the smaller one. How much does a pile of sand weigh if each dimension is 4 times larger? Right? So we know it's 64 times bigger. I need my calculator for that. So 64 times 400. I don't want to think about that. 25,600. 25,600 pounds. That is a lot of sand. All right, we've just got a few more. A brick of peat moss weighs 45 pounds. Again, weight, so volume. How much does a similarly shaped brick of peat moss weigh if each dimension is 1/3 as large? All right, kind of on repeat here. So dimensions again are sides. So 1/3 is large, which means the perimeter is 1/3 as large, which means the area is 1/9 as large, and the volume is 1/27 as large, right? And since we're talking about weight, that's a volume dimension technically. So we're going to set up our proportion. If you're setting up a proportion, we want to use that 1/27. So 1/27. All right, so the brick of peat moss weighs 45 pounds. How much does peat moss weigh if each dimension is 1/3? So the one we're finding is the smaller one. All right, and so on this one, we're actually going to divide because it's 1/27 the size, right? So 27x equals 45. Let's see, obviously we can reduce that. I'm going to leave it as 5/3, however. So x equals 5/3 pounds. That sounds really weird. I'm still going to write it though. 5/3 pounds. All right, 1 2/3 pounds. All right, let's see. Number 5. 2 prisms are proportional. The height of one prism is 2/3 the height of the other. All right, well, clearly height is a one-dimensional measurement. So when I'm making my SPAV chart, right, I'm going to be doing 2/3, which means my perimeter ratio is 2/3, which means my area ratio is 4/9, which makes my volume ratio 8/27. All right, now let's go see what we're looking for. If the lateral area, oh, ding, 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 that means we're using the area column. Go ahead and highlight that. I'm going to go ahead and get my, oops, sorry about that. I'm going to go ahead and get my proportion set up because I automatically know this is a lateral area problem, so we're going to be using that 4/9. If the lateral area of the larger prism is 81, what is the lateral of the other? Now, clearly, I can see across that I'm just multiplying by 9. So if everyone's cool with it, I'm just going to go ahead and write 36, right? And you can cross multiply and divide, and you'll get the same answer. All right, last one. 2 cylinders are proportional. If the radius, again, radius is a one-dimensional measurement, so it's technically a side, if you will. If the radius of one cylinder is 1 and the radius of the other is 4, how do the volumes compare? Okay, so they're not actually asking you to solve a problem or find a missing piece of information. It's just saying the radiuses are 1 to 4, and radiuses are one-dimensional, so we put them in the side column, which means the area is 1/16, which means the volume is in a ratio of 1 to 64. Right, so I'm going to say the larger cylinder has a volume 64 times bigger. Okay, and that's just what I'm going to write as my answer. All right, I am hoping your SPAV charts make sense, everybody. And then your homework is pretty much just as short as our notes today, right? So good luck with that. All right, I'll see you guys in class.